let's get some more speed physics done. Session 15. Uses and dangers of radioactivity. Explain the effects on the atomic number and mass numbers of radioactive decays. But at foundation level, we don't need to do that anymore. Nuclei that have undergone radioactive decay often undergo nuclear rearrangement with a loss of energy as gamma radiation. Explain what this means. Basically means at first you've got something that's unstable. So what it does is it gives off some gamma and then it becomes stable. It'll usually give off gamma after it has emitted an alpha, a beta plus or a beta minus. So the gamma just comes afterwards when the atom has still got a little bit too much energy. Describe the dangers of ionizing radiation in terms of tissue damage and possible mutations. So ionizing radiation can damage your tissues and it could cause cancer. And what it does is it mutates the DNA of the cell. How can we keep ourselves safe? Common sense stuff. Put some kind of shield in between you and it. Stay away from it at a great distance. If you do have to go close, do what you need to do and then go away. And if you do have to pick it up with some tongs. Don't pick it up with your hands. You can also wear a dosimeter badge, which would tell you if you've been exposed to radiation or not.
Radiation can also be detected by using photographic film. The film is put inside little badges called dosimeters. The film starts off transparent and gets darker when radiation reaches it. The darker it is, the more radiation you've been exposed to. People who work with radiation on a daily basis need to wear dosimeters so they know if they've been exposed to ionizing radiation.
List the precautions taken to ensure the safety of people exposed to radiation. Well, I've just said that in the answer before. Describe the differences between contamination and irradiation. Contamination is when you've got the radioactive material on your body. Okay, so it's touched your skin, you've got it under your fingernails or something like that. So no matter where you go, you're taking it with you. You've been contaminated. Irradiated, it just means you've been close to it and you've been exposed to it. However, as soon as you walk away from it, you are no longer irradiated. Particles released during radioactive decay can have different energies. A suitable unit for these energies is mega electron volt. For one type of decay, the particles released have energies between 4 MeV and 10 MeV. The graph shows how far the particles with these energies travel in air. State the name of this type of particle. So distance travelled in air. Well, if it goes about 10 centimetres, that would be beta. Travelling 1 or 2 or 3 centimetres, that's alpha. Gamma travels an infinite amount of distance in air. Use information from the graph to describe how the distance travelled in air depends on the energy of the particle. So you can see the energy of the particles getting bigger and bigger as we come along here. And basically it's travelling further. Okay, so as the energy increases, the distance you travel also increases. Ionizing radiations are emitted by unstable nuclei. Some unstable nuclei decay by emitting beta-minus radiation. Describe the process of beta-minus radiation. So that would be when a neutron splits up into a proton and the beta minus. Protons are positives, beta minus is negative, plus and minus cancel out to give neutral, which is what the neutron starts as. So the charges on the left hand side of this arrow is equal to the charges on the right hand side. and the mass is also the same. Protons have got the same mass as a neutron, and the mass of a beta is negligible. Explain what happens to the mass number and the atomic number of a nucleus when beta minus emission occurs. That's not foundation anymore. Medical staff who use radioactive materials need more protection than their patients. Describe some precautions that medical staff can take to ensure their safety from radioactive materials. Right, there's the radiation. Stay away from it as far as you can. Put a shield in the way. Also wear lead shielded apron. If you do have to look through some glass, use lead glass, because radiation finds it very difficult to get through lead. And if you do have to pick it up, use some tongs, which are like the big scissors. So that question was the same as before. And that's that. Thank you very much. And you hit the like button, because that helps me out a bunch. And if you want to see more videos like this, please subscribe to my channel and turn on notifications using the bell icon. I'm producing new content weekly. Thanks very much. Work hard, be nice, and I'll see you in the next one.